This is an experiment to control the brightness of LED and also verifying the base current IB in microamps and collector current in milliamps. In this we are using BC107 transistor, 100 kilo ohm fixed resistor, 1 kilo ohm potentiometer, and here I am using a 5 volts power supply we should use. So instead of power supply, regulated power supply, I am using one 5 volts adapter. I will show you later, and 470 ohm fixed resistor and 2 multimeters. I am making them as ammeter and 1 LED. This is 1 kilo ohm pot and LED and 100 the force how much it is 100 kilo ohm resistor and 470 ohm resistor. This is 470 ohm resistor, this is 100 kilo ohm fixed resistor, and this is BC107 transistor. This is notch, near to notch the terminal is ammeter, middle one is base, and this is collector. This is 5 volts DC adapter I have used. Since 5 volts power supply I am not using, I have cut the cable here and removed 2 wires. The red wire is representing plus 5 volts and the black wire is negative or ground. In this experiment, you should connect the middle terminal of the pot to the positive terminal of the ammeter, negative terminal of the ammeter to the 100 kilo ohm one end resistor, another end 100 kilo ohm resistor to the base of the transistor, and emitter of the transistor and the second terminal of the potentiometer and the negative terminal of the battery all should be connected to one point, and it is made as a ground. And to the collector we are connecting 470 ohm resistor, other end of 470 ohm resistor to negative terminal of second multimeter and the positive terminal of the second multimeter to cathode of LED, anode of the LED to the positive terminal of the power supply. If you have 100 kilo ohm pot, directly you can use 100 kilo ohm pot. Since I don't have 100 kilo ohm pot, I am using 1 kilo ohm pot and 100 kilo ohm fixed resistor. If you have 100 kilo ohm pot, no need to connect this resistor. So if you don't have, then only you connect 1 kilo ohm pot and 100 kilo ohm fixed resistor. How to make the connection, in previous video I have already explained, and the link of that video is given in the description box. You just go through that. Only modification, we are connecting two extra multimeter in this experiment. This multimeter I am making as base current, and you should keep this in microamps, 2000 microamps. Second multimeter I am making as a collector current, to measure the collector current, and you should keep in milliamps. Initially LED is in off condition, so this is base current, this is collector current. Base current is also showing 0 and collector current is also showing 0. Now I will rotate the potentiometers lightly in clockwise direction. See, LED is lighting up very less brightness. Okay. Now it is increasing the brightness. The base current is showing 2 microamps, and you can check the collector current, it is amplified, it is 0.6 milliamps. Now I will again rotate in clockwise direction. Brightness still increased and the base current increased to 5 microamps and the collector current is 1.34 milliamps. Brightness again increased, base current is 9 microamps, collector current is 2.4 milliamps. The base current is 14 microamps, brightness is more here, collector current is 3.7 milliamps. Brightness further increased, base current is 18 microamps and collector current is 4.74 milliamps. Base current is 25 microamps, collector current is 6.3 milliamps. Base current is 28, collector current remained same, 6.69. So this is the last position. I can't further rotate it. So the maximum value I am getting base current is from this potentiometer, 31 microamps, and the collector current remained same, 6.85 milliamps. By this stage, the brightness is very high and transistor is entered into the saturation region. So this is called as saturation region. When I make this 0, LED is completely off. Now I can say the transistor is in cutoff region. Cutoff region means transistor will be in off condition. When I increase slowly, so that according to the base current, the collector current is also increasing linearly. Then we say that transistor is acting as in active region. So when the base current is increasing, according to that collector current increases linearly, then transistor will be in active region. When completely on, transistor is in saturation region. When completely off, 0 I'll make. When completely off, the transistor is in cutoff region. In this way, the transistor is acting as amplifier as well as a switch. So at the higher value of potentiometer, it is going into the saturation. At the lower value, it is going into the cutoff region. And in the middle range, it is acting in the active region. The same experiment I have done in a Proteus software. So you go through that, you watch that video, you will understand and how the current is varied in software also. So initially when base current is 0, collector current is also 0, I will call the transistor is in cutoff region. So as I increase the current, for 1 microamp I am getting 0.21 milliamps collector current. For 5 microamp, see from 0.21 it is increased to 1.19. When I increase 7, 1.99. When I increase to 12, 1.2 it is becoming 3. When I increase to 6, 18 it is becoming 4 point something. When I increase to 23, 4 to 6 it is increasing. When I increase to 33 it is becoming 6.91. After 37, see the current, it is almost remaining same, 7.0, 7.09, 7.12 up to 48. This will be in a saturation region. Transistor will be in saturation region. From here to here, transistor is in active region. So in active region, we will check the value of beta. Beta is current gain of the transistor. Beta is equal to IC by IB. So let us check for this. IC is 3.28 divided by IB is 12 microamps. 10 to the power of minus 6. This is 10 to the power of minus 3. So let me calculate and tell you. So I am getting 273. So this is the correct, because for BC107 transistor, the beta value ranges from 100 to 300. So I am getting the correct value. Let me check for another reading. Consider for 23 microamps. For 23 microamps, I am getting IC current as 6.08 divided by 23. It is 264. So 264. This is also within this range. So now we can say that transistor is working properly and it is amplifying the base current.